Hi everyone. By now you should have completed the exploration activity that had you look at a business in bankruptcy, which should have followed the model of a quadratic function. So I just wanted to take a minute to talk about just one really key point from that assignment and connect it to what we're learning about today, which is solving quadratics by graphing. And we'll look at graphing by hand a little bit, but mostly focus on graphing with technology, more specifically a graphing calculator. So here I have pulled up your assignment in just kind of a Word document format. So the scenario here was that you were exploring a business's profits with relationship to time and the number of years of operation. And one of the things I asked you to explore in the survey, and I got your responses, was after how many years will the business reach the maximum profit? Well, we just have to think about what does maximum really mean? It means the highest point on the graph. So if we look over here, I typed in this function into the online graphing calculator link, which I provided to you, and we can see that if profit is the y values, the highest y value it would reach is this point right here, which is roughly after 3 years, because we're looking at the x coordinate of this if we care about time. Right. Another question that I asked you, and again, I'm not going to go through all of them, is after how many years will the company be bankrupt? Well, if they're bankrupt, that's assuming that they have no profit or zero amount of dollars. Since the profit is represented by the y-axis, we're going to look for when y is 0, what is that corresponding x value, which is how many years. So if we come over to our graph, really the point and the coordinate we care about is the x value right here. And you can see that it's highlighted as about 5.77 years. So not quite 6 years yet, but pretty close to that. So what I wanted to show you is that if we're relating a quadratic function to a real-world scenario, some of the points we really care about are these maximum values, which we've already explored, is called the vertex. It's a critical point. Another thing is the x-intercepts right here. There are these important parts of data. So we're really going to be focusing on these x-intercepts and why we care about them today with regards to graphing. So I want to relate this to something that you already know, which is linear functions. So back in the day, I might have asked you to solve a linear equation that looked like this, and we'd be solving it for x. I want you to note how this equation is in slope-intercept form, what we're used to seeing, y equals mx plus b. All right, so if we just perform the basic operations to get x by itself, we're going to isolate the term with x, so we're going to add 6 to both sides. If we rewrote that, we'd be left with a 6 on the left and our 2x term on the right. And now to get x by itself, to undo that multiplication of those two values, we would divide both sides by 2 and get a solution of x equals 3. Now that's the algebraic method for solving these equations. Now I just want to show you the relationship with these linear functions and how this solution corresponds to the graph of this same equation. So let's go back to our graphing calculator and type in this 2x minus 6. All right, I want you to pay close attention to how the 0 really just replaces the y value when it's in that format. So we're really trying to find what is x when y is 0 given this equation. So let's type in that 2x minus 6 into our calculator. So we'll come over here. All right, now I want us to look. When y is 0, right, that's really what we said we were solving for, what is the x value? So if we look right here and I hover over that point, and I can even zoom in better so you can see it, we are simply hitting the x-axis at 3. Oh, look at that. It's the value that we got before. So we can see there's this direct correlation basically between the solutions of our equations we get algebraically and the x-intercepts we find when we graph it. Now this isn't just true for our linear functions, it's true for quadratics as well. So I just again wanted to relate this to something you already knew. Sorry, let's go back here. All right, so when we're asked to solve quadratics, it's really the same thing as finding the x-intercepts, just reiterating that again. And sometimes if you think about it, since quadratics are these parabolic shapes that U-shape, we might have one solution, meaning the graph is hitting the x-axis one time. We might have two solutions, meaning the parabola is hitting the x-axis two times. Or there might not be a solution at all, and that would be the case when your parabola isn't hitting the x-axis. Okay, and again, because there's this direct correlation between the number of solutions, the solutions themselves, and where your graph hits the x-axis. So let's just go through a few of these. If we look at this picture right here, take a minute, think, how many solutions would it have? This would have one solution because we can see our parabola is hitting the x-axis at exactly one spot. Although it's a little bit blurry, we can see that value is at -4. So the solution to this function, if we had it written down, would be x equals -4. Okay, and it's only one case. If we look over at this picture, here's our graph, our parabola way up here, and our x-axis is way down here. Since we're not intercepting the x-axis at all, there's actually no solutions for this case. So it would be unsolvable if we actually tried to do it by hand. How about this one? Let's look at it. Again, here's our x-axis, and here's our parabola way down here. Is it hitting the x-axis at all? Nope. So this means that, once again, there would be no solutions. Let's just try two more. Now, if we look at this graph right here, we can see that the parabola is hitting the x-axis at two different spots. The same thing over here. Now, with this graph, it's a little more clear to see what those actual values are. We can see that we have the solution of x equals 2 and x equals 4, the two values where your graph's hitting the x-axis. Now over here, it might be a little bit more unclear of what those actual values are. Yes, we know there's two solutions, but can I, without a doubt, conclude that this x value that our graph is hitting at x equals 5? Probably a good guess, but what if it was 5.01, 5.02? If we are not exactly sure, this is when technology becomes a really good alternative. And so if we have the function, it's good to type it into the graphing calculator and actually find those specific values. So I'm going to go back to my graphing calculator real quickly and show you how you can solve problems if you are given the equation, if you have this piece of technology, which you generally will, okay? And even though we're going to learn alternative methods to solving quadratics later on, this is always a really good way to check your answers if the technology is available. So let's try x squared minus 11x plus 28. So we have this trinomial quadratic. So if we graph it, we can come over to our picture here. Sometimes if we graph these by hand, which we'll learn how to do more so later, they'll nicely cross at the grid points, right, where these grid lines are intersecting one another. And we could create this by hand by creating a table of values, right, just with some basic input values for x and getting outputs of y, and we've done that before with linear functions. So if it crosses nicely by hand, we wouldn't even really need the technology. We could just look and see, okay, we're crossing at x equals 7 and x equals 4. There's our two solutions, right? Other cases, we might have it so it's crossing at a decimal value. So what if I just change that c value to 25 instead? If we were to graph this by hand, we wouldn't come up with these nice numbers here. And you can look, we're intersecting the x-axis at 3.2 and 7.79, right? That's something we would not be able to figure out what those decimals were by hand, so technology can be a really good alternative, right? So just to summarize, what I want you to get out today is that when we go to solve quadratics by graphing, we're looking for the values of the x-intercept. So where's your graph hitting the x-axis? We can sometimes have cases, again, where there is no solution. So if your graph isn't touching the x-axis at all, like we can see here, here's our x-axis, here's our graph way up here, there's no solution, and that is possible, right? So whether graphing by hand or using technology, Graphs can provide us with a lot of information. All right, hopefully this was helpful, and you can go back and replay this as many times as necessary as you complete your assignment.